Let's talk about simplification of fractions a little bit. So we've explored that 20 divided by 100, viewed as 20 whole objects divided into 100 collective pieces, or we could just look at that as 20 hundredths. One thing we've divided, if I do 3, 4, 5, 6, 7, 8, 9, I'll do 10 in one direction, and then I'll do 10 in the other. Remember, this is 10 segments, which is only 9 lines across. So that's 4 lines, 5 lines, 6 lines, 7 lines, 8 lines, 9 lines across to create 100 different even pieces. I'm going to claim 20 of them. 20 is going to be 2 whole rows of 10. So let's claim those by shading them as green. Now, if we look at this, this is something that is a true representation, but we could make a simpler representation. For example, as I just said, there are 2 groups of 10, 3, 4, there are many groups of 10 in here. And so if we instead look at all of these groupings, I'm going to sketch the last ones out quickly, we could draw the exact same quantity using a simpler picture. So that instead of dividing it into 100 pieces, we could divide it into 10 pieces. So we'll do 3, 4, 5, 6, 7, 8, 9, 10. If we have 10 pieces and we claim 2 of them to be green, it's the same quantity as what we had in the original picture. And in fact, we can do this one more time, because we can take this and we can group this into groups of 2/10, which will create 5 total groups. So that would be 3 total groups, 4 total groups, and 5 total groups. So if we want, we can actually represent this more simply. We can represent this using a diagram where we have only divided it 5 times. So that'd be 2, 3, 4, 5 times, where we're going to shade again the first part green. Now, this is a much simpler picture to draw. It's a simpler way of explaining the idea of 20 hundredths. So if we'd like, we can look at how we would change this using our arithmetic, our algebra, and follow it through. What we did in the first time is we recognized that 20 and 100 are both numbers that have groups of 10. So we could look at this as saying we have 2 groups of 10, use our multiplication, and on the bottom we had 10 groups of 10. Well, 2 groups of 10 and 10 groups of 10 would really just be 2/10 times 10/10. 10/10 is weird, that's really just 1. So 2/10 times 1 is 1 time of 2/10. That's just 2/10. So this is the simplification we did for our very first step right here. We turned 20 hundredths into 2/10. Then we looked at this and said the 2 can actually be thought of as 2 times 1, and the 10 can be thought of as 2 times 5, that there's a common factor, a common multiple in both of those of 2, which is 2 halves of 1/5. Well, 2 halves of 1/5 is just 1 whole 1/5, and 1 whole 1/5 is just a fifth, which is exactly what we got here, 1 of 5 shaded pieces. So simplifying fractions comes down to recognizing what numbers you can use to multiply both the numerator and the denominator. To help with a strategy that organizes our thoughts related to this, you can consider what is called a factor tree. So a factor tree is nothing more than a way of organizing our thoughts if we'd like to think about what different numbers multiply into a larger. So we can start with 20, for example. Well, what can we use to multiply up to 20? We could use 2 and 10. What can we use to multiply to create 2? Well, the only whole numbers that we could use would be 2 and 1. And we already know that dividing by 1 doesn't change its appearance, so that's not going to be helpful. So once we get to these numbers we call primes, these numbers that can't be divisible by anything except for themselves and 1, we'll just stop our factor tree. But let's go on to the 10. 10 can be factored into 2 and 5. We already know that 2 is prime, and if we think quickly about what can multiply to create 5, we're left again with only 1 and 5. That means that 5 must be prime. Well, what about 100? Let's do 100 a little quicker. Maybe we know that 100 is 10 times 10. And that 10, as we saw on the left, is 2 times 5. Well, we now know, then, that 20 hundredths is the exact same thing as, instead of 20, we'll write 2 times 2 times 5. Instead of 100, we'll write 2 times 2 times 5 times 5. Remember, in math, we're always allowed to replace things with other things that look different but mean the exact same. So we've replaced 20 with something that is 20. 2 times 2 times 5 is 20. And we've replaced 100 with something that is 100. 2 times 2 times 5 times 5. But even more importantly than that, we've replaced it with something that shows all of the possible groups that we could possibly create. Because on the numerator, we have the ability to group things twice, which if we go to any one of these pictures, before our fully simplified one, we can see that we can do groups of 2, and it would work out okay. In fact, we were able to do that twice in a row. We were able to group a second time with 2s, and then more than that, we were able to group with 5s at any point that we would have liked. And so if we look at the 2 over 2 and the 2 over 2 and the 5 over 5, these are all just hidden 1s, similar to when we said that 2 halves is a hidden 1. So that means that all of these are just 1s. This is 1 over 1 times a 5. And that means that we can simplify this to be 1/5. This is a very useful strategy, and it's important that we always try to simplify our fractions because they allow us to recognize connections in math between different stories and concepts that might appear different but actually mean the exact same.